about how we wanted to use deep learning techniques to actually bring fun back into shopping furniture. And as I mentioned before, yeah, I'm a founder and a very young startup, so probably none of you have ever heard of me or of my company. So bear with me, I'd like to introduce briefly myself, the company, the product, before going into the tech. That's me. I'm representing the Taiseiku UG, and I'm the CTO there, and in my former life I was actually a physicist as well. So after my PhD in quantum physics, I decided I need a new challenge of the academia, so I was looking into the industry. And having heard a lot about machine learning, I was pretty much intrigued by this topic. And so I started working as a data scientist in a Berlin-based company specializing in cloud and hosting, and also data, big data, and data analysis. And I was working there for 2.5 years, cross industries, and a lot of smaller projects, pretty much prototypes. During this time in the company, I also met my co-founder, Nietner, which has a very, or has a background as, or studied an MBA, and has a strong sales and entrepreneurial background. And yeah, the usual thing while traveling through customers and back, basically, we spent a lot of time together also in the airport waiting for the next flight. And we're discussing ideas and problems, and we also came up with the problem of refurnishing our apartments. And we were just wondering, why is it so hard for us to actually get this projects, this private projects solved? Because we do have the money, but somehow it's not going to work. So we started thinking, and pretty much from my perspective, it was pretty clear. So I simply lacked the imagination. It's probably the same problem that most of you have experienced before. So it's really hard to actually imagine how furniture will look in our own room. And coming from this data science background, I was also reading a lot of computer vision papers at this point in time. So I was starting, my brain was starting to work, and I was just coming up with some ideas how deep learning techniques might help solve this kind of problem. And but we were actually even more lucky because when we discussed this idea and followed it, there is another technological trend appearing, namely last year at the AR released the AR kit, and what we see now is basically that a new kind of, it's not so new, but the AR technology reached a new level of profoundness and being really stable, having a nice user experience, and all the big players are actually working on that. So it's not just Apple, it's also Google, and we see also rising in hardware, so it's going to go more into hardware devices, namely glasses, for example, Magic Leap. And the nice point about it is when Apple started to release this, it was actually at the same time available on 300 million devices. So probably almost all of you have that got an iPhone have access right now to use augmented reality applications. And this is still rising, so we expect in the next 2 years to actually reach 4.3 billion devices that are able to run this kind of applications. So we're talking about a very huge market here, and that also connect, of course, to a huge opportunity to actually get access to this market within the next 5 years. There is an expectancy of $60 billion, and this market is mainly driven at the moment by, of course, the hardware producers, but fastly adopted by retailers and e-commerce, for example, IKEA and Zara, and there's a lot of applications happening right now. And that was pretty cool for us, because that's pretty, it's a nice technology for the problem that we had at hand. And starting with this and having this kind of, well, tech background and the pretty neat use case of furniture shopping at hand, we decided we want to build our own company, and we want to be the leading tech company to empower AR commerce for the industry. So we really want to develop this kind of technology and provide and help with it the industry, especially smaller companies maybe, that are not, don't have the power to actually do it themselves and struggle with digitization, to really help them get into it. And we see AR as a very crucial component, a very helpful component when it comes to visualization. But we're also pretty much convinced that you can't think AR without AI, without the artificial intelligence behind it. Because in the end, if you really want to enrich the environment around you with digital content in a meaningful way, it's crucial that you understand the environment. And there we're in the direction of image processing. But firstly, coming with this idea, where do we stand right now with providing that to the industry? So just a short breakup here. Teseko is actually very, very young. So we started last year in September as we entered the Axel Springer Accelerator Program, which is a startup accelerator program lasting 100 years. That helped us a lot with some first funding, but especially business models, and allowed us to build our first demo app. If anybody is interested in this kind of accelerator, just keep in mind it's not named like that anymore, because Axel Springer actually changed their collaboration partner and got together with Porsche, and now it's called APX, the Axel Springer Porsche Accelerator. But just, yeah, whatever. The main point here is that during this program we founded our company in the beginning of November, so actually we're just half a year old right now. We were extremely lucky to find pretty close by the end of this year of last year in December, our first investor investing money into us, which allowed us to actually start hiring people. So we've got the first 4 employees now since March this year for the app development, but also data science and sales and marketing. And with this team we actually started to work on our product RoomAR, which is a smart AR product for the interior industry, and we're about to close our next funding so that we can actually really start working on this product till the end of this year. We're pretty much financed. So yeah, so as I said before, we are pretty convinced, or we're not the only ones, but we're pretty convinced by augmented reality, and we really think that this kind of technology will change the way that we shop, that we experience brands, that we interact also with our environment. And when it comes to furnishing industry, we think that it really helps accelerate the sales and increase efficiency here. And talking a lot about augmented reality, I've always had the impression that it's really hard to transport what it actually is. So just to give you a short impression, it's a video that we actually recorded on the EMM, the International Furnishing Fair in Cologne this year. As you can see here, that's where I try out our prototype at that point. And it's crucial here to see that augmented reality is really placing stuff into the real world. It's not VR with closed up digital environment, but you're really interacting with the real environment around you, and that in a very stable and neat fashion. And that's already cool, I think, as a visualization tool. But it's not just cool; it also generates benefits for the brands and for the industry. So, namely, to accelerate sales online as well as offline. Especially online, this industry is very struggling a lot. Generates a new kind of brand experience, allows to address new target groups and present some new innovative touch points. But visualization, as I mentioned before, is very cool. Well, I think that's just where the story starts, basically. Because what this augmented reality technology actually allows you is, on the one hand side, to put digital content into the real world, but on the other side, it's some kind of door to some new kind of data source, because you can also, of course, take information out of this kind of application, and especially when it comes to the video stream that we've just seen. Then we have a lot of images, we have the interaction data, we have data about what people actually try out, what kind of product, how do they configure them, and we want to differentiate, or we want to exploit this kind of data that we we see here, in order to make a really personal experience. And that's where the AI comes in. So I think the visualization right now is the easiest part, as we do have the SDKs available. It's not so hard to build this kind of applications, but the personalization, dealing with the data that is available now through this technology, that's the really hard and interesting part. And yeah, so the idea is to collect a lot of data and try to personalize the experience. But of course, if we do have data, we can also analyze them for ourselves, for the performance of the app, and in the end also bring it out into the wild and help the industry understand their consumers, their markets better. But the topic for today is the personalization part, and the question here that I actually want to tackle now is how do we actually do this personalization here? And it pretty much breaks down to the idea that we want to apply machine learning techniques to understand the furnishing style from the images that we get via the app from the video stream. So basically, when the user is using the app, they do have a video stream that will take out several frames and try to understand basically the environment that the user sees to help them enrich them in a meaningful way. So to make some product recommendations that are really suitable for the user. And yeah, the question is, how do we start? Or basically the challenge to rephrase it once again is you have a picture from this video stream from the app, and you have on the other side some products. And now you want to match these products to the picture and to the style. And I mean that's not a trivial task here. I mean you're paying a lot for interior designers to actually solve this problem for you. And most of them, I mean even the experts do have problems with that. If you ask 40 interior designers, you probably get 40 recommendations on what to actually put into them. And so to really have this kind of answers, like you might try out this one, but maybe forget about this that's not really suiting your style. So this kind of challenge, that's actually what we're trying to solve here. And of course, it's a very visual topic that we're talking about here. That's why pictures is basically pretty much the basis for this kind of recommendation. And yeah, looking into research and reading through, then you find a whole lot of ideas what you can actually do with pictures and deep learning approaches and understanding images in multiple dimensions. And that's fair enough, and that's all cool ideas, but being a startup, being lean, agile, and have to act fast. But not necessarily just because of this reason, but I think in the general way, it's always the best idea to start with the most simplest approach that you can actually get. And be it just for a baseline model, start with the most simplest idea and then iterate on the results afterwards. And that's actually what we want to do. So I'd like to just briefly introduce our approach. So we'd like to start with, we start with building up a database, of course, that's always the foundation for all data science. And this database basically includes labeled image data as well as connected products, right? Because somehow we need a match between picture and product in order to make some recommendations. If we do have this kind of data, we will use or train our own neural networks to actually get a meaningful feature representation, basically mapping an image to numerical vector representation. And the easiest approach that we follow straightforward is then to say, okay, we'd like to find out similar images. So if we see a picture from your room, we want to understand what's in our database that is closely by or resembles similar to your room, for which we know product data and recommend it to you. So the next step would be to find somehow a distance measure or some kind of metric that allows you or allows us to actually decide what is in similar images to that what we actually see. And if there's sufficient time, I'll just shortly comment on how this approach might be improved in the first stage. But starting with a build of the database. As I mentioned, of course we have pictures, but as well we need products, right? I mean, matching both sides. And the easiest way how we get some data source from where we have a connection between pictures and products is simple, some kind of catalog, right? Some kind of furnishing catalog where you always have some kind of staging image related to some products that are actually presented in this image. So this is a starting point to build up a database where we have both images related to products, and of course it's more than just products when we come to think of styles, so we need probably a little bit more of information. We need some kind of information about what kind of room is it. Maybe there is already some possibility to determine a style, or one trains an style classifier, and to extract colors, because color is obviously also very important in this kind of problem here, in order to match products and recommend them already in the correct color scheme, for example. And in the end, of course, it would be nice if we have more objects than maybe just the one that are advertised in the catalog. So respectively, we're also talking about identifying objects and images in order to improve this kind of data quality. But that's an own talk, and I won't go into detail there. Yeah, having this kind of data set established, we go ahead and train a neural network. And although there are some expert presence here, I'd shortly like to introduce for the rest what a neural network actually is. So you can basically picture it as a network from some kind of nodes that are arranged in layers and connected with each other, and each of these nodes basically represents some mathematical operation on the input data. And the data is traversed from the left through the right, being an image on the left side, for example, these kind of faces here, and on the outside there's usually some kind of classification task at hand. So in this case might be, is there a picture, is it a face or is it no face, or maybe who is visible in the face. Might be a task for this kind of network here. And the important point that I actually want to bring out here is how does this learning process actually works, and what does this network actually sees in the picture that allows them to classify it in the end. And the point here is that it learns hierarchical features on these images that it sees, in the sense that each of these layers extracts some kind of feature of the image, and these features are basically, or in this case here, ordered hierarchically, so that we start with some very general features in the very first layers, and they become more and more complex and more domain specific in the later stages of this network. And yeah, that's already quite fine. However, the reality is that it's more complicated like that. So usually that's even a simple structure, but it's more complicated as what I've shown before. So here's just the idea is the same. Just imagine all these sheets, all these planes here contain a lot of these neurons that we've seen before. So usually thousands, hundred thousands of neurons in each of these layers. And the idea is still the same. The input data, the image, enters the network from the left, it traverses through the network, and generates some output in the end. And usually we can divide that in several stages. Usually you have this kind of neuron stage here, where neurons try to extract meaningful features from the images. They will have some kind of compressed representation of these meaningful images in the end, which we call usually feature vector. And in the end, we will have some kind of classification stage that actually solves the problem. And what do we need that for? As I mentioned before, we'd like to find some similar images, and for that we need this kind of numerical representation, which is the feature vector, because in the feature space we can pretty neatly measure distances. And so what we usually do is we just get rid of the classification task. So one step back, maybe in our case for these interior images, we might use these kind of networks to for example, classify what kind of room is a picture. Is it a living room, a kitchen, a bedroom? And that already helps us to find some more specific and domain-relevant feature extraction in the phase before, in this phase before here. And or another task might be to classify styles. So there are data sets available for modern styles, Scandinavian styles, so interior styles in general. And you can also imagine it to be this kind of task, so that the network needs to classify by style. In any case, the idea is that we get some very specific and meaningful feature representation when training a network on this domain-specific tasks. However, that usually requires you to have a lot of data available, because you need to somehow tune all these thousands and hundreds of thousands of parameters, or even millions in these kind of networks. And luckily there's another idea how you can deal with that, and that's transfer learning. And here basically the idea is not to train your own network, but to use a pre-trained network already and get rid in this pre-trained network from all the domain-specific parts and the classification parts, and just concentrate on the more general features. So what you can imagine is you take some input image in the end, you choose some available networks. They're pretty, as you can see here, so they're pretty different also in architecture, and they're usually trained on completely different tasks. But nevertheless, most of these networks have at some point very general feature extraction layers. And so you can always, as a valid starting point, to actually try out these kind of approaches as well, to construct your feature vector in the end. So these both approaches might be available to get a very meaningful numerical representation of the picture. And if we have that, then we can try to define the distance matrix and find similar images. And so the idea is basically all of our databases going through and be processed by this kind of networks. And for all of our images in the database, we find some vector representation. Usually that's a high-dimensional space, which I can't show you here. So what I can show you is some projection into a plane that might look like that. So that's a different image data set here, but I think the idea can be made clear here. Namely that if we're lucky, we find similar images in similar corners of the space. For example, down here where all is blue, I don't know if you can recognize that, but it's basically all some kind of boats. So that's nice to have. They're all pretty neat together. They don't all have something in similar in this kind of boat. And if we look into another corner of this map, we see a lot of deers out in the wild. So they're similar with each other. But the important point is that the distance between these two groups is rather large. So they're well separated, actually. We do have some vicinity where pictures are similar. But if we do have a good feature representation, then we also can use the distance between in order to separate between different. In this kind, we can make a difference between deers and ships. But in our case, we like to have some difference in, for example, Scandinavian style and modern style, or between a living room and a bedroom. And so that would be the idea in the end, to say we get some image out of the application. We have an impression or an image of the user's room. We look in our database, what are images that are similar to this room of the user, and then we see what kind of products are actually attached to these images, which we might recommend afterwards. Since time is running out, I will spare you this little improvement step here and just go through what I actually want to take you away. For one thing, I would really like to inspire you thinking about AR technology, because this is really an interesting technology with a huge potential in its market and enterprise ready right now, and it's going out into the mass market. And it has a very huge potential for for company purpose, so say brand experience, or generate new sales opportunities, but also maybe in the engineering field as a supportive tool. And but in the end, the main point is this AR technology not just allows you to put digital content in the real world, but also to get access to some kind of really new and very interesting database. And this database is pretty much visual on most of the parts, which is actually cool because that allows us, or this can be exploited with knowledge that we actually accumulated over the last decades in computer vision and really leverage the potential of this kind of new technology. And yeah, with this, I'd like to end my talk. I hope it inspired you a little bit to think into this new directions, and if you have any questions or want to discuss maybe possibilities, opportunities with these kind of technologies, also in other industries, you're more than welcome to address me. Thanks.
Thanks, Christian. We have a couple of minutes for questions. Are there any questions?
Do you cross-mix the products from other catalogs?
Yes. In the beginning, the challenge is that we are starting from a business side as a B2B white label application, so we will have several customers with their own catalog. But yeah, in the end, to make it really good, we need to be as broad as possible when it comes to products and images as well. So cross-mixing is, a crucial part, I think.
Yeah, thank you very much for an interesting talk. But my question would be, can you use also personal features of people to whom you make a design? Because as far as I understand, you use pre-trained network, are you using TensorFlow also, Google, and you has existing furniture what you can find somewhere. But maybe it's not exactly, we are talking all talking about personal data. That you can use some kind of personal feature and you can say that exactly this picture would suitable for this person, but maybe for another person would be something different.
Not quite clear if I understood you correctly. So in the end, we also, the approach that I introduced right now is pretty much picture-based, right? So each user has its own room and will take its own picture and will get its own recommendation. On the other hand, a slight problem here is that you might try to refurnish your room in some other sense, and that's actually a different part of this kind of recommendation that we namely also get feedback and questionnaire from the users as well. So there's basically in the end there will be two kind of data that will be processed by this kind of recommendation. You can do it separated as well, but I guess the combination is better, namely to have pictures as well as asking the user what are your preferences, what is the style that you actually want to have in your room, what kind of textures, colors do you like in your room. To just make it more attractive and more fitting basically, because having just one of these data sources will probably give you bias. For once, if I just ask the user, then maybe the user doesn't really know what is best for him. And on the other hand, if I just have the image data, then I might just lose the track to what if the user actually wants to shift to another domain or to shift in style, basically. So in the end, the combination of two of these data sources will probably give better results. But fair enough.
Yes, fair enough.
Okay. Other questions?
Where are you based?
In Berlin.
Simple answer.
Next question.
Yeah.
Other questions?
Yeah. Are you afraid of competition with the big players?
No. Of course, there's a lot of competition going on. Am I afraid? No. Actually, no. I'm not really afraid. This firm can start building it anew without actually, being liable in some legal sense. So it's a tricky thing.
Okay. Thanks again, Sam.